Welcome to this presentation on branch and board, a powerful optimization technique used to solve complex problems with many possible solutions. My name is Jois Romauli Simarmata, NPM 23312229. Class Informatics 23 FX. Okay, what is branch and bounds? The branch and bounds algorithm systematically explores a set of potential solutions to find the best one by literally dividing the problem into smaller subproblems and using bounds to eliminate non-optimal solutions. An application this approach finds use in various fields, including operations research, computer science, and artificial intelligence. To solve optimization problems in areas like schedule, resource allocation, and logistics. The branch step, dividing the solution space. The branch step involves first systematically breaking down the problem into smaller subproblems, essentially dividing the solution space. This division is based on the designation variables that define the problem. Each subproblem inherits constraints from the original problem, but with a resection based on the branching decision. The result of this process is a tree-like structure with the original problem at the root and each subproblem branching out as more contractions are added. And how branch and bounds works. And first one, initialization began by selecting a starting node, usually the root of the desiccation tree, and intelligent the upper and lower bounds for the optimal solution. And two, branching. Explore potential solution by branching from the current node, creating new subproblem with additional constraints. And three, bounding. Calculate bounds for each subproblem, estimating the optimal solution within the branch using reelection or other technique. And for pruning, prune branches that cannot possibly maintain the optimal solution by comparing their bounds with the current best solution. And the branch step, dividing the solution space. And once start, the algorithm begins by dividing the original problem into smaller subproblems. And to divide, this division process is continued iteratively, creating a tree-like structure where its node represent a subproblem. And re-explore, the algorithm then explore the subproblem in a systematic way. And the bound step, estimating optimal solution. And one, lower bound. For minimization problems, a lower bound is calculated for each subproblem, which represents the minimum possible value of the objective function for that subproblem. And two, upper bound. For maximization problems, an upper bound is calculated representing the maximum possible value of the objective function. And prune, subproblem was bounds are worse than the current best solution can be pruned, meaning they are not explored further. Okay, branching strategies and the first versus breadth first, and this one depth first. Okay, depth first. This strategy explores one branch of the tree to its full depth before moving to another branch. It is typically essential for finding a good solution quickly, but might not find the optimal solution. And breathe first. The strategy of explore also problem at given level of the tree before moving to deeper level. It's more likely to find the optimal solution but can be slower than the first. Okay, there is bonding technique, relaxation and dual problem. In this one, relaxation, this technique involves sampling the constraint of the problem to obtain a relaxed version that is easier to solve. And dual problems, the dual problems of the original problems can be used to obtain bounds on the optimal solution. And application of brains and board. This is first step one is scheduling. Finding the optimal schedule for tasks with constraints like deadlines, resource availability, and resource allocation. Determining the best allocation of resources to different projects to maximize profit or efficiency. And step three, logistics. Optimizing routes for delivery trucks or finding the most efficient way to transport goods. And step 4, other application, brains and bone is also used in various other fields, including finance, healthcare, and engineering. Okay, advantage and limitedness of the approach. Advantage provided a guaranteed optimal solution. Eventually, for many complex problems, versatile and adaptable to different problem types, and limitations can be computationally expensive for very large problem may not fit a good solution quickly. Complexity can make it difficult to implement. And affectance of brains and bone. And step 1, quarantine optimal solution. Embrace and bone quarantines, finding the best possible solution for a given problems, ensuring the most efficiency and effective outcome. And step 2, efficiency for complex problems. If effectively handles complex optimization problem with numerous variables and contradictions, providing a structured approach for finding solution. And step 3, versatility and adaptability. It can be applied to wide range of problems across different domains, making a versatile tool optimization. Okay, limitation of brains and bone. Computational code is for very large problem with many variable and contradiction. The computational requirement of brains and bone can become significant, potentially leading to long processing times and to finding good solution quickly. While brains and bone guarantees finding the optimal solution, it may not always find a good solution quickly, especially for complex problems with a vast search space and implementation complexity. The complexity of the algorithm and the need to careful define branching and bounding rules can make it challenging to implement and maintain. Okay, and conclusion, brains and bone in real-world optimization. Brains and bone remains a powerful tool for optimizing complex problems in various domains. Its effectiveness in tackling challenges across different industries underscores its importance in the world of optimization. Okay, say this is my presentation. Thank you. Bye bye.